So we will continue our naming introduction with just looking at ionic compounds. So ionic compounds are named because they combine a cation with an anion. So remember, a cation is a positively charged ion, and an anion is something that is negatively charged. And ionic compounds always combine in a way so that the ratio of cations to anions results in an electronically neutral compound. So for binary compounds, again, two-element compounds, it's always a metal and a nonmetal. So if I'm looking back at my handy-dandy chart, there are two different binary ionic compounds that I can have. I can either have what is called a main group, that's this pink, with a nonmetal, or I can have a transition metal, that's this purple that even extends beyond to the post-transition metals, with a nonmetal. So that's two different ways in which I can have an ionic compound. Now, the general format, the most simple way that I can combine things in a binary compound is simply by stating the name of the metal and then the name of the nonmetal, chopping off its last syllable-ish, and adding IDE. So for example, I have here lithium chloride. So lithium, I keep the name of the metal, and chlorine, I take off the ene part and I add in IDE. Similarly here, I have NaCl, that's sodium chloride. So transition metals will have that general format of the metal and the nonmetal dropping the last syllable and adding IDE, but it adds an extra twist to it. And the twist is this: transition metals, there are many different charges that it can take. It will always be a cation, it will always be a positively charged ion, but many of the transition metals can take multiple charges depending on the conditions in which they are created. So there's some ambiguity. If I just said, get me the manganese chloride, you wouldn't know which manganese chloride. There could be up to 5 different manganese chlorides to choose from. So I have to choose the one that gives you the right formula, and that will be to determine which charge the transition metal takes. So nonmetals always take the same charge. Transition metals can vary, so that's why I have to add this specific information. The transition metal is the one that's causing the problem, not the nonmetal. So I have my metal and my nonmetal, but in between the space, I have parentheses and a Roman numeral, and that Roman numeral is equal to the charge of the transition metal. It's not the subscript. It might be a subscript in there, but if it is, it's just a coincidence. So chlorine takes a -1 charge. I have 2 of them. I only have 1 manganese to balance that out, and so that manganese must have a +2 charge. So this is manganese 2 chloride, just to show you that the subscripts don't cause the Roman numeral to be what it is. I have CuO. Oxygen takes a -2 charge. I have 1 copper to balance it out, so it must have a +2 charge. So this is copper 2 oxide. So you can write your Roman numerals either by just the straight up lines without the serifs, or you can have them with them. It's up to you, but they can't be lowercase, so don't put 2 lowercase i's. And then finally, the last type of ionic compound has more than 2 capital letters. It's called a ternary compound. If it has more than 2 capital letters, it contains a polyatomic ion. And a polyatomic ion is a group of atoms that travel together as a unit and have a charge, either a negative anion or a positive cation. It balances the same way, but the naming is a little bit easier. If it takes the place of the nonmetal, I just simply name the metal and the name of the polyatomic ion. If it is taking the place of the metal, then I just name the polyatomic ion and I name the rest of the compound as if it is. So this is lithium, the name of the metal, plus nitrate, the name of the polyatomic ion, and this is ammonium, and this is the name of the chloride. So you may ask yourself, how the heck am I supposed to figure out how to do that? And that will be in our next video on polyatomic ions.